Good morning from Cologne. Fine to take this opportunity to talk on the Sigmafine Virtual Summit 2021. I have to do now the INEOS Cologne Case Study. My name is Alexander Gammersbach. I'm working at INEOS Manufacturing Deutschland in Cologne as a team leader of the site balancing team. Before I start, I give a short agenda here, what I'm talking about to you in the next minutes. First, I want to give a first introduction into INEOS, the INEOS group, and the INEOS Cologne site here where I work. Then I will summarize the challenges of the Sigmafine introduction project we had here 2 years ago. The modeling we do, the data flow we set up here in the Cologne's IT systems, and then afterwards the first learnings after 2 years of this new system in operation, and in the end the short view on next possible steps we want to do. We want to go forward with Sigmafine and PIMSoft. So the INEOS group was founded at the end of the 90s. And in the first 10 years, there was a rapid growth of these chemical groups by more than 20 acquisitions of companies or parts of companies which are very well known, like BP, ICI, Bayer, BASF, Dow, or Solvay. And today, the INEOS Group has in total 194 manufacturing sites worldwide in 29 countries. And with this 61 billions in sales in 2019, the INEOS Group is within the top 3 of the chemical companies by sales. 26,000 employees worldwide and organized in 36 businesses and up to 20 million tons of refinery products. Now a view on the Cologne manufacturing site. This was founded in 1957 by BP and Bayer, and it's located in the north of Cologne. Our production capacity here is about 5 million tons of petrochemicals per year. And with that, we are some of the largest cracker complex in Germany. In total, 21 production plants. From point of view of the logistics, we are located at the River Rhine, and we have also jetties and capacity to take material from or to barge. There's a railway crossing directly through the plant, and in the east side you will see also a motorway. What you don't see are the pipeline connections. We are also connected to the RIG pipeline system in parallel to the River Rhine for ethylene, and the refinery product pipeline RMR. From point of view of businesses, we have olefins and polyolefins production plants here in Cologne. We have the business unit acrylonitrile, ethylene oxide, and ethylene glycols, propylene oxide and propylene glycols, and diisobutylene. In total, 4 different businesses on site. And if you want to know the size of our site, it's about 1.9 square kilometers. The football supporters know these are 270 football grounds, but I like to compare it more to Monaco, which has 2 square kilometers, and we do on nearly the same sites, a lot of chemistry, not as much as billionaires, but millions of tons. Yeah, now I want to start with the Sigmafine Introduction project and the challenges and this as a starting point of our work. In the former time, the Cologne site was balanced in a monthly process, once a month. And the balancing rules, they were customized in our local SAP system. And as time goes on, people need to update the SAP system and want to bring in a new SAP system. And then we started, are we really, do we have a good balancing process and what could we do with that? And the wish was that we change the way of modeling, not customizing anything in the SAP system, but started with a software and a functionality of balancing. And the goals were we want to have more accurate data, and we wanted to introduce a single point of truth, an SQL server called KSB Cologne Site Balancing. What principles we developed in the balancing process? First, we realized it would be a good idea to change from a monthly balancing process to a reconciliation on a daily basis. And we want to have this process as automated as possible. And therefore, we use the scheduler to do things in an automated way. And then also automatic publishing the results on the KSB server. And we started to modeling. This was new for us. How does such a model have to be set up? And we decided to make one global model representing the entire complex in the mass balance system. And we use this global model in the process book to balance the whole site in mass. And to make it more easily to work in this, we created 20 different displays. So we have multiple views of the site models. And our energy were not balanced with masses, and there we introduced 4 special utility models for steam, water, nitrogen, and oxygens, so they can be balanced in volume or energy as needed. And here is the representation of our global model. We presented 18 processes here in Cologne, which were also balanced. Not all our processes can be have a mass balance, and therefore we decided to balance 18 processes. And from the point of view of the whole model, we have this 186 nodes. We have more than 200 tanks and nearly 1,000 flows in this model. And to make it more easily to understand, we also use different colors for different products. In totally more than 700 meters and more than 120 receipt and shipment points. We also use a Sigmafine to calculate additional information that this were added then to the flows, that we were able not only to have a reconciled mass of, but also further especially content information or in a reconciled way. I want to talk a little bit about the data flow. And I said we introduced KSB as a central SQL database. in which Sigmafine publish data, and this SQL database is able to then give the information needed for the SAP system directly to the SAP system. We also had a planning system in Cologne, which was developed here in Cologne. It's called DSP. They also need of balanced data, and they were also fed automatically by the KSB database. Sigmafine itself get also information, the logistics information we need from the KSB database, and the plant data from our local historian, which is OSIsoft PI. And the rest of the reportings is done then from the KSB server. Yeah, how does our scheduler work? We're starting the overnight process at 1:45. Then the scheduler starts the system and collecting the first data. And on 10 minutes to 2, the cases were created, the transfers were collected, the inputs, and the first one is made and published then at 4 o'clock to the external SQL database, and this automatically also sends the data to the SAP system. Then in the morning, in the normal work time, the balance were checked by my team, and all the data were validated and again published on demand if the results are accurate enough. We look the cases after the month-end process is finished. This is the last possibility that we can book anything in the SAP system, and then we also log the Sigmafine cases in order to be sure that now no changes will be done, because we cannot change anything in our SAP system then. Yeah, interesting always are the learnings from the project phase. So firstly, the introduction of Sigmafine was really a huge change in the whole balancing process, changing from monthly to daily, changing from self-made balancing rules to a strict math. This was really big. We also learned how to encourage people to use the tool and how to make them accepting the new tool. And we learned that there are two things give advantage to you. And the first thing is the visibility of the model, that you have a model and can show it. This makes it, especially for production people, much easier to understand what's going on. And the second thing still worth to put work in is the availability of the data, the reporting, because this is what people see when people see the results and can make their own ideas of it. And last but not least, the quality of the input data is key, because Sigmafine always finds a solution and publish it. But if you have problems with your input, then also your output is in a mess. You see it's GIGO, the principle, meaning garbage in, garbage out. And therefore, we developed a procedure for our daily checks I talked about. So first we learned about this automated overnight ones, that it's better first to publish the measured values and not the reconciled one. Then in the daily work, we check all the notes with high and unusual differences. We're looking for the completeness of and accuracy of the logistic information. and looking what's going on in the plant. Do we have usual or unusual operating conditions, and which plants are in operation, and is that what's in the model really the way the plant operates, and how can we adjust this in daily checks. And our goal is also the DX1 below 5%, and then can we publish, as I told, in the morning update, after the morning update and publishing check data, we use the reconciled data set in the SAP system. Then the learnings from using Sigmafine. First learning is that the system is flexible to add additional measurements in the system, and this gave a higher accuracy of the whole data. And also our production teams started really to look for additional measurement and gave us additional measurements we hadn't before into the balance. And this was a good sign that the people starting to work with the possibilities of Sigmafine and wanted to add measurements to the balancing, new measurements to the balancing system. Also, the month-end process is now smoother because we only care about the last days and have finished the work on the first days of the month already, because we have at the end of the day already the best version of yesterday's in the system. And it's key really to look the cases after the month's end process in order to keep all the systems aligned with the same kind of information. Then we learning about model maintenance using Sigmafine, and there we realize that you need strict rules if you work on your models. And we also installed a development system, and all changes need to be checked in the development system before you go productive. And also, if you do the changes, do checkups that the transfer is the right way. And this should also fit into the daily work if you want to change things in the model. So we learn to define a special point in time when we do changes on the productive model. So do it most likely at the beginning of a month, and then you will be able to use the same model the whole month until the month end process, and then you can do it again, or I can do changes again. Yeah, what we still want to do in the next step is to improve our model to be as realistic as possible, and therefore is this key to have a good documentation of your procedures, of your working, of your reporting, and of the way you want to change things. Then if you doing your work, you check your checks every day, you will find days which won't really good results, and then you started what's going on there, looking for deeper problems in the models and in your data. And from that, we developed a robust management of change process for our models. And the next step I'm very keen on is to introduce the Sigmafine Hub. I think in this summit, we will see a lot of the possibilities of the Sigmafine Hub, and hopefully it's a good tool to further improve the accuracy of the data set. And yeah, we want to see the workflow capabilities which can make life a little bit easier for people working every day with Sigmafine, especially to the possibilities of communication within the team and with the people working in the same models at the same time, knowing about each other. So we quite interested in this and in this possibility. Yeah, and I want to say thank you for this opportunity and for the time you gave to me, and I could present the introduction of Sigmafine at INEOS Cologne. Thank you very much, and I'm open for questions.